the first thing I'm going to need you to do today is to take out your notes packet that you picked up at the door. As you're doing that, please make sure that you've turned your project in. If you are 1B or 5B, you need to turn it in on table 5. If you are 8B, I need you to turn your project in on table 6. If you have your rubric, that also needs to be back there. Your homework from last class also needs to go in the box in y'all's designated color. Please make sure it gets there. I will come by this weekend and get it. So remember, we only have next week. Is the rest of the 6 weeks. Your test for vocabulary will be on Tuesday, and your naming and bonding test will be on Thursday. As soon as you come to class on Tuesday, we will be taking the vocab test. Okay, so starting organic chemistry. Organic chemistry is the study of carbon and its compounds. Organic compounds have a few properties. I know you heard the term polar in 8th grade. It was a tested thing when we were talking about water, and you might have talked about that. That's why it has some of its properties. Also, you might remember that oil does not mix with water, and it's because of its polarity. So similarly, organic compounds are nonpolar. If you think about all the compounds you saw last year in biology, most of them were organic compounds, which meant we were carbon-based. Therefore, they do not mix well with water. Also, insoluble in water. They are non-electrolytes, so we are not going to be conducting electricity. In general, covalent compounds do not do that. They react slower, and that has to do with how big they are in general. And just remember that they're covalent compounds. So the first thing we're going to do is I want you to draw the Lewis dot structure of carbon. So remember, the Lewis dot structure is the symbol with the valence electrons around it. And so carbon has 4 valence electrons. Every element wants to have 8. So if we're looking at this, carbon can have 4 more electrons. So it bonds 4 times. Remember we talked about last class that covalent compounds, they share electrons. So that's where this comes from. We're going to be sharing these 4 electrons with something else to make us have 8. And I want you to draw this on the side in one of the margins. A hydrocarbon is exactly what it sounds like. It's a compound that consists of only hydrogen atoms and carbon atoms. Today we're only going to talk about hydrocarbons, and then on Tuesday after your test you'll have 30 minutes to take your vocab test. Remember, no word bank, only fill in the blank. Definitions will be given. You must write in the word. So after that 30 minutes we'll do our goals for this week, and then we'll go ahead and we'll learn a little bit more organic chemistry with elements other than just hydrogen and carbon. But today we're just going to do hydrocarbons. The first type of hydrocarbon are alkanes. They are saturated compounds that contain only single bonds. They only have single bonds. Okay, and the general formula for these will be CnH2n plus 2. where N is the number of carbons. Sometimes this concept is hard for students to grasp, but you need to keep in mind that we're looking at we are going to start writing the formulas for the different alkanes. So again, N represents the number of carbons. So if I have one carbon, then 2N plus 2 would be 2 plus 2, so we would have 4 hydrogens. As we continue, if I have 2 carbons, then 2 times 2 is 4, plus 2 is 6. And then the third one is 2 times 3 is 6, plus 2 is 8. We're going to go ahead and start drawing them and naming them. So, we skipped C on your notes. The first section is alkane, of the alkanes, is the CH4. As we continue talking about alkanes, the first one is methane. So remember, I have one carbon. Carbon can bond up to 4 times. It will always bond 4 times because it would like to have 8 total electrons. So in order for it to do that, it will have 4 hydrogens attached. For the next alkane, the second one, its name is ethane. Ethane has 2 carbons, and they are both attached to one another. When we do these, they are always going to be attached to one another. So, again, each carbon can bond 4 times. It was already bonded once to each other, so then they have 3 carbons total around them. The third alkane is called propane. I am sure most of you have heard of propane. It is we use it to use grills, gas grills, or propane tanks usually. Also, propane is on King of the Hill. I've had somebody every class mention that. So again, the carbons are attached to one another. This carbon on the end only has one current bond, which means it'll bond 3 more times to have 3 hydrogens on it. That's the same situation for this end carbon on the other side. It had 1 bond already, so it had 3 empty spots. This middle carbon, however, if you see, it already has 2 bonds. So that means it can only have 2 hydrogens attached to it. This is called the Lewis dot structure. We have one other way we can write this, and this is called a line structure. Okay, so the way a line structure works is that every point on our line is a carbon. So there's 1 carbon, there's 2 carbons, and here's 3 carbons. When these molecules get very large, and they're called macromolecules, or even the molecules that you used in biology last year, those were macromolecules. Drawing them is really complicated, and it takes a long time if I'm drawing all my hydrogens. The hydrogens are still there in this line structure. We're just not going to draw them because we understand that this is just a hydrocarbon. There's only carbons and hydrogens attached. Let's continue with our alkanes. So we were up to 3 carbons. So if we have 4 carbons, I have C4H10, and this is called butane. Again, some of you may have heard of these. They use butane burners when they cater meals and they're trying to keep them hot. Those little flames that go under the pans to keep them warm. Those are butane burners. You might have seen them at a quinceañera or maybe a wedding. Okay. Also, when we have a compound that has the same molecular formula but different structures, we call these isomers, and we'll talk about those in a minute. But let's go ahead and draw butane while we're here. So if we're drawing a Lewis dot structure of butane, again, the carbons will always be attached to one another. Then we need to process how many empty spaces we have. This carbon on the end has one bond already, so it needs 3 more. The next carbon has 2 bonds, because a line is a bond, so it needs 2 more hydrogens attached to it. Same with the next carbon. Then this last carbon only has 1 bond, so it can hold 3 hydrogens attached to it. And if we were drawing the line formula, it would be 1, 2, 3, 4. Where this is carbon 1, 2, 3, 4. Remember, if you have questions with these, you need to come into tutoring. The other way I can draw this, so this is one version, I could also do this. This still has my 4 carbons, and they're still attached to one another, but now they look slightly different. And again, we're going to fill them in with hydrogens where we can. Okay, so I have 9 hydrogens. This middle carbon has 3 bonds already, so it only gets 1 hydrogen to give us 10. If we were to draw the line formula for this, I have 3 carbons that are in a row, and I have 1 carbon coming off of the chain. So this is 1, 2, 3 in the chain, and then up here, this is where my 4th one is. Okay, we're not going to double count. That center one has already been counted when I counted 2. These 2 together are isomers for C4H10. I'm going to draw a couple more. So I'm going to do pentane, which is C5H12. But I am no longer going to write the Lewis dot structure. I'm only going to draw the line structures because we're getting too big at this point to continue to do that. So if you look on H, your prefixes are the same from 5 up as for covalent bonds. The only things that are changing for these are 1 through 4. So pentane looks like this, normal pentane. Okay, so we have 5 carbons, everything else is attached to it. Pentane has isomers. So if we take this last line off and I move it here, that is one of my isomers. And I still have 1, 2, 3, 4, 5 carbons attached to this. So it will still have that exact same formula. This is not a new isomer. This same structure could be flipped and put into this same orientation. So it's the same thing. There's one other one for pentane, and it looks like this. I know it looks different. I have carbon 1, 2, 3, and then 4 and 5 are up here. Again, the center spot, we are only counting it 1 time. So all of these are isomers, which means they have the same formula, different structures. Let's talk about how we name things like this. So you notice I've been counting my carbons. So this is pentane. And if you have not found room to start writing this down, the back of the packet is blank, the whole page. So you can write there. So if we're looking, and it's not just a normal chain. You start counting your carbons. The piece that's coming off of it, this part right there, is called a substituent group, and you're going to name it last. We do, however, want it to be on the lowest possible piece of a chain. So, this part right here, this is my chain. This chain's name is butane. Okay, because there's 4 carbons, and 4 carbons is butane. When I look at this, my substituent is at carbon 2. And if you look right below the prefixes, it says names of alkyl groups. And if there's a 1 carbon coming off, it's called a methyl. 2 carbons coming off is an ethyl. And then it just continues. And this happens to all be one word. It's just not squished together as I would like it to be. So that corresponds to that top one. This one down here, if I'm looking at this one, the longest carbon chain I have is propane. Now here, I've had many students tell me that this, at the top, these are an ethyl group, which means 2 carbons. But an ethyl group would be 2 carbons in a chain, not 2 carbons coming off separately. So this is a methyl right here, and this is a methyl right there. So this is 2-dimethyl because there's 2 methyls coming off of the chain. So that one is 2-dimethyl propane. I'm going to do a couple more examples that are different. Okay, so this one looks a bit different than we're used to. The point is, you need to find the longest carbon chain. So we're going to start counting. 1, 2, 3, 4. This is 5. If I go up here to this corner, that's 6. That is not my longest carbon chain. We can continue going. 6, 7, 8. So my longest chain, so this is my parent, is octane. Then if we look, we have 2 methyl groups coming off of the chain. There is one at 2, and there's one at 5. So this is 2,5-dimethyl, and it is again di because there's 2 of them. Remember, if you have questions, you need to come into tutoring. I will be here Monday morning. I will be here Monday after school. We're going to go ahead and move on to alkenes. So all of that was just alkanes. Alkanes is very similar, except now we have a double bond. So a double bond would look like this. So if I had 2 carbons, they're double bonded together. That's not an equal sign. They're attached by 2 bonds instead of the 1 that was previously attaching them. Which would mean I have 1 less space to put a hydrogen on each carbon due to the fact that I have another bond occupying a space. Its formula, generic formula, is CnH2n. And remember, that's because I've got a double bond that's taking up a space. This one is named ethene, E-N-E. This part is the suffix. It's because it's an alkene. Up here, they were only single bonds, so they were alkanes. So it ends in A and E. I do want you to go ahead and draw this structure. I am only going to tell you this one name. So on your paper, A says the first member of this series is C2H4 and is named blank. Its name is ethene. And then I want you to draw the structure. We're not going to name it another way. We're going to do a couple more alkenes. The second member of this group is C3. And remember, it's CnH2n, so this becomes 6. You need to keep in mind that methane looks like this. And the reason I'm not starting with one carbon is because they cannot be double bonded to anything else. The carbon needs to be double bonded to another carbon in order to be considered an alkene. So this one looks like this. And you can choose which carbon to double bond. One of them, it doesn't matter. And there's our 6 hydrogens attached. Again, if we're drawing our line structure, which this is much easier, you draw just a second line where that double bond is, and now it's become an alkene in your structure. This alkene's name is propene. Again, it's propane, but you take off the ane and you put ene because it's got a double bond. Then the third member is C4, C4H8. So this is called butene. I hope we're catching on. So I am not, well, I guess I will draw the Lewis structure for this. So C, 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 C. Okay, so notice I have 3 on this end, 4, 5, 6, 7, 8 carbons, hydrogens total, and this would be drawn like this for the line structure. Now I can move where that double bond is, and when I draw the isomers, which it says it has 3 possible isomers, I'm going to only draw the line structures. So I can move that double bond to be in the middle. And if we are looking at our Lewis one, I can move it there, but that does affect where my hydrogens are. 1, 2, 3, 4, 1, 2, 3, 4. So now this one over here is getting my extra hydrogen. 3, 4, 5, 6, 8. Yes. That's what it would look like. Or we could have one more like this. So this thing's name is just butene, and it's because the double bond is at the end. In the event that the double bond is not at the end, you need to specify where it's at. So the second isomer's name is 2-butene because the double bond occurs at the second carbon. This bottom one is a propane, but because it's got this double bond, it's propene. You need to take into account that this is 2, where our methyl group is coming off of, so this is 2-methyl propene. Again, that ene is coming from the double bond. These are the 3 structural isomers. There's one more type of hydrocarbon that we're going to discuss today, and it's called an alkyne, YNE. And I want you to go ahead and fix the carbon, the triple bond that's in parentheses, on your notes. So on your notes, it's just a double bond. I need you to add the third bond in. And its general formula is CnH2n minus 2. So again, we're subtracting another one. So the first one has C2H2. So we would have had 2 times 2 is 4, but then we subtract 2 of them. So we only have 2 hydrogens total. This thing's name is methine. And it looks like this. Again, the triple bond is in between the carbons. And then each carbon can have 4 bonds. It already has 3 that they're sharing, so they each only get 1 hydrogen. The second member of this family would be C3H4, because 2N would be 6 minus 2 is 4. This is called propine. So the only thing that's changing is this suffix right here, Y-N-E. And again, we connect our carbons. You choose one to be triple bonded. Okay, let's talk about why this very center carbon doesn't have any hydrogens on it. If we look here, I have 1, 2, 3 bonds on one side on the left, and then I have one bond over here on the right of that central carbon. So it's already got 4 bonds. It does not need any more. It's happy. If I were to draw its line formula, it would look like this. So it has one on top and one on bottom because now it's a triple bond. I'm going to do one more example, but it's going to be a little bit more complicated. Okay, so step 1, count the parent chain. 1, 2, 3, 4, 5. The parent chain is pentane, but it has a triple bond, so it's pentyne. At carbon 3, I have an ethyl, because now I have 2 carbons that are attached to my chain of carbons. So this is 3-ethyl pentyne. I hope this video helped. If you need any more help, this will be posted on my website, or you can go to khanacademy.com and they have lots of great help. Y'all have a good day. Remember, you have homework. You also have the UT online homework that's due tomorrow at midnight, and a current event that's due tonight at midnight.